Hello friends, welcome back to our channel The Tool Engineer. Today we are going to discuss about a very important topic in we can say tool engineering, manufacturing engineering and production engineering, that is limit, fit and tolerance. I will try to explain details about this topic. Keep watching, and if any doubts coming after the video, then comment below and I will give you answers about what are your questions. Then, first one is limit. The extreme permissible value of a dimension are known as limit, or we can say the limit are two extreme permissible size of a part between which the actual size of the part is contained, or a point or level beyond which something does not or may not extend or pass. That means it is saying that anything having the boundary that does not exceed, that is called limit. If you are if you are telling about one example, if you are going to one destination, let it be from one point to another, we cannot go away from that second point. That is called limit, that is the boundary. In this picture, I will try to explain all the things about tolerance, allowance, limit, fit, what is zero line, what is maximum size, what is minimum size, what is the upper deviation and what is the minimum lower deviation. The picture having two halves, first one is whole half and second one is the shaft half. The whole having minimum size, maximum size, and the shaft also having minimum size and maximum size. And one is zero line. Zero line is called the basic size. The basic size means the designer given the size of the part or of the component, that is the basic size. From the basic size, what is the deviation? The minimum size is the hole having the minimum size of the hole, inner side of the hole is the minimum size, and maximum size means from the minimum size how much distance it is going away, that is called the maximum size. Same thing in shaft having maximum size and minimum size. The diameter of the shaft having some maximum value or the some minimum value is the maximum and minimum size. And what is the deviation? The upper deviation of the hole is from the maximum size to the zero line is called the upper deviation, and from the minimum size to the zero line is called the lower deviation. Same shaft having from the zero line to the minimum size is called the lower deviation, and the from the zero line to the maximum size is called the upper deviation. And what is called the allowance? The allowance is nothing but the gap between shaft and hole. The gap between shaft and hole. It may be negative, it may be positive. Positive allowance and negative allowance. If the gap is very low, or the shaft or diameter is more than the hole diameter, is the negative allowance. If the shaft diameter is lesser than the hole diameter, is called the positive allowance. If you are talking about the fit, the degrees of tightness or looseness between two mating parts that are intended to act together is known as the fit of the part. Fitment, we are talking about fitment. If a person is wearing a cloth, is this fitting or not, loose or tight? In the sense we are calling that fit. If you're talking about the types of fit, is there is three types of fit. First one is clearance fit, second one is interference fit, third one is transition fit. The clearance fit is what is called clearance fit. The hole is greater than shaft, that is called clearance fit. That means a shaft is putting inside the hole, clearly going, there is no obstacles are coming. Second one is the interference fit, means the shaft is greater than hole, the shaft is greater than hole. That means a shaft cannot put inside the hole easily, or that does not coming inside the hole. And third one is transition feed, means hole and shaft are same. That means a shaft can go inside the hole, not easily, not tightly. That means full fit is there. If you are talking about three feeds difference, there is the difference that we can denote these feeds within a proper example in hole and shaft basis system. First one is hole based system. Hole based system, what is called hole based system? The size of the hole is kept constant. Shaft size is varied to get different feeds. That means hole basis system, hole will be kept constant and shaft value will be different, maybe loose, tight, something, but the hole will be constant. And the shaft basis system, what? The shaft remains constant, the size of the shaft is kept constant and hole is the varied in different fits. In this picture, the clearance, transition and interference fit in hole based system is given there. That means a hole is kept constant but the shaft size is minimum, zero level or the maximum. That means first one is clearance, transition and interference. If you are talking about the applications of the fits, first one is clearance fit. Applications are loose fully fits, that means D8, D9, D10, lubricated bearings F6, F7, F8, lightly loaded shafts, that is G5, G6, etc. Socket and spigot of joints S5 to H11. These are all the examples of clearance fit. We denoting in these symbols, these letters. Second one is transition fit. There is very accurate location, spigot couplings. These are JS5 to JS8. Second one is precision joints like K5, K6, K7. We are denoting like this. Forced assembly is required M5, M6, M7. These are the transition fits. And the interference fit, fixed buses, standard fresh fit like P6, P7, P8, tight press fit R5, R6, R7, etc. These are the examples. Last one is tolerance. Tolerance means the algebraic difference between the maximum and minimum limits. The algebraic difference between the maximum and minimum limit means the two limits, there is the difference, that is called the tolerance. And if you're talking about the types of tolerance, first one is unilateral tolerance and second one is bilateral tolerance. What is the unilateral tolerance? When the dimension of the part is allowed to vary only one side of the basic size, that is called the unilateral tolerance. That means one side is vary up from the basic size. That means plus 0.001, either minus 0.001. Only one thing is there. And second one is bilateral tolerance, means when the dimension of the part is allowed to vary both the side of the basic size, that is called the bilateral tolerance. That means the value of the basic size may vary plus 0.001 and minus 0.001, plus minus 0.001, like that. In this picture, I am showing you the unilateral tolerance and bilateral tolerance. You can properly understand. There is the given the dimension of the shaft is diameter plus 0.000 and minus 0.004. That is the unilateral tolerance, because here given one value is there, that is minus 0.004. But the bilateral tolerance side, there is given the diameter is 20 plus 0.002 and minus 0.002. That means plus minus 0.002. And second, there is also a figure showing unilateral tolerance and the bilateral tolerance. If you watch properly, then you will understand better. If you talking about the grade of tolerance, the standard tolerance is various grades of tolerance are defined using the standard tolerance unit, that is micron, which is the function of the basic size. That is I is equal to 0.45 d root cube plus 0.001 d. This is an example where d is the is the geometric mean of the lower and upper diameter of a particular diameter step within which the chosen the diameter d lies. One note is there, especially the tolerance is expressed by the symbol plus minus. Okay. One question, most important question arising here, most of the persons confusing by the difference of allowance and tolerance. Many persons are thinking allowance is same as tolerance, but that's not. Allowance is the gap between the shaft and the hole, but the tolerance is the difference between the upper limit to the lower limit. These are the difference. Thank you for watching this video. If this video is useful to you, please like, share and subscribe.